Hello! It is our pleasure to welcome you all to today's webinar, Secrets of the Desert. Today's workshop is part of the Arts Integration webinar series, A Science Around Us, presented by Southern Utah University and Weber State University. My name is Tamara Goldbogen, and I'm the Beverly Taylor Sorensen Endowed Chair in Arts Learning and the Director of the Arts Learning Collaborative here at Weber State University. I will invite my colleague Elisa to introduce herself.
Yes, my name is Elisa Peterson, and I am the Beverly Taylor Sorensen Endowed Chair of Elementary Arts Education at SUU in Cedar City, Utah.
Before we jump into the webinar, I'll cover a few housekeeping items, introduce today's presenters, and briefly go over the schedule. Today, during the webinar, if you need any tech support, please email Samantha Steffen at samanthasteffen@weber.edu. We're going to put that email into the chat for you. We suggest that you view today's webinar on a laptop or a desktop computer for the best viewing experience. You can adjust window sizes by using the slider in the border located in between the shared presentation and the presenter boxes. At the conclusion of the webinar, your browser window will open up a survey for you to complete. When we receive your completed survey, we will then be able to award you relicensure hours for Midas. By the end of next week, we'll add you to a Google Drive folder that will contain today's presentation and other resources. We are recording today's webinar, and we'll add that to the Google folder when it's ready. Don't forget your materials for today's webinar. We are putting a list in the chat now. We encourage you to work alongside our presenters today as they demonstrate different arts integration activities and approaches. You'll want to make sure that you have a printed or digital copy of the diatom reference sheet. Great. We'll also put a link to that reference sheet into the chat. So we have some amazing presenters for our webinar today. We have Elisa Peterson, Southern Utah University. I'll be presenting for Weber State University. We have Dr. Amy Miner, In Focus Education Group, Dr. Jackie Grant, Grand Staircase Escalante Partners, and then we have Erin Roundy, Olivia Roundy, Deja Mitchell, and Samantha Steffen, all from the Arts Learning Collaborative here at Weber State University. This is our schedule for this evening. After my introduction, we're going to do a quick check-in and look at how today's webinar is going to connect to USB-E standards. Elisa will then lead us in a visual art activity and get us started on that. Then we're going to check in with Jackie, and she's going to take a look at Utah deserts so we can learn more about our Utah deserts. I'll be creating a rabbit puppet. Samantha will be leading us in a music workshop. Erin and Olivia will be leading us in a diatom scratch art activity. And then we'll check back in Elisa for more of this visual art painted paper landscape activity. Then Deja will be doing a movement activity. And then we'll finish off by checking back in to making connections with the USB-E standards. And of course, one of our favorite parts, we're going to invite you to share any artwork that you're working on at home, and we'll take a look at that. And then finally, we'll have an opportunity for a Q&A, and then when you leave the webinar, the survey will pop up for you. Just a few more things. Just make sure you have that printed or digital copy of the diatom reference sheet, link in the chat, and make sure that you're working alongside our presenters today. Here are our learning intentions and success criteria for today's webinar. At the end of this webinar, you should have at least one idea of how to integrate science and art into your classroom and be able to recognize intersections and overlaps in the USB-E standards. For some of our webinar portions tonight, we will be using pre-recorded videos. Amy Miner was unable to join us live tonight, but she generously agreed to send us a recorded message. So we're going to watch that video that will set up the standards connections that we'll explore in this webinar.
Hello, I'm Dr. Amy Miner, and I'm here to help make connections with the standards. As we begin, I wanted to emphasize the USPE SEED science and engineering practices. These practices and skills are embedded throughout all grades and all of the different science standards. With these practices, we encourage students to ask questions and define problems, analyze and interpret data, use mathematics and computational thinking, construct explanations and design solutions while obtaining, evaluating, and communicating information. One of the things I love about this integrated webinar is how we bring those beautiful engineering practices integrated into the various art forms. At the core of our conversation today are the science standards, and at every grade level, we'll be exploring how living things adapt and engage with their environment. In first grade, we talk about the needs of living things, including food, water, shelter, and temperature, and specifically the patterns of external features of living things, including plants and animals, that help support them in surviving in different locations. Notice, even embedded in this first grade standard, we talk about animals living in cold locations that have thick fur, or for our webinar, animals in desert climates that stay awake at night to remain cool. Or when you're looking at the dance part of our webinar, you'll learn about plants that come out only at night. In grade 2, we talk about living things and their habitats, specifically their physical characteristics of plants and animals and how they reflect the habitats in which they live. That continues on when we look at grade 3, looking at the effects of traits on survival. Specifically, I wanted to point out the variations in traits between different plants and animals adapting to their environments. Again, all the kinds of things embedded within these living things that help them adapt and survive in environmental changes and organisms. In grade 4, we typically see things and learn things about how our environment has changed over time and throughout history. So we really emphasize environments both in the past and the present, plants and animals, and those internal and external structures that serve various functions for growth, survival, behavior, and reproduction in their different environments over time. And in 5th grade, we talk about the cycling of matter in different ecosystems, specifically looking at environments and resources. 6th grade is a great time and a great place to learn more about deserts as we look at the stability and change in ecosystems and the consistent interactions that occur within and between various species, plants, and animals in the different ecosystems and how they're affected by their environment. Notice how in standard 6.4.3, they specifically highlight deserts. So with that, I'm excited to give you opportunities to learn through dance, music, art, drama, and as we learn more about the Utah deserts, be watching for these important science standards.
Hello. I am now going to invite Elisa to lead us in created painting papers. For each activity tonight, we'll put the specific supplies you need to work alongside us in the chat.
Awesome. Thanks. So we're just going to do this kind of quickly. If you're doing this project, these are not any supplies that we included in the kit. And so this is an optional thing. In the kit, we included a variety of painted papers, but if you want to make your own or see how to do that, I'll show you now. Let's go to the next slide. In this project, we are going to be creating paper landscapes that are in the style of this artist, Sarah Winkler. So I just wanted to show a few of her beautiful kind of abstract landscapes. Awesome. Let's just click through these kind of quickly. You can see the atmosphere here, the perspective that things are far away and they look smaller. So when I do this, I talk to students about the colors that we see. And so I just put these two pictures here to show some of the Utah desert colors that we see. We can see blues, but the sky isn't just blue, it's got white in it, maybe a little bit of yellow. Sometimes the sky is darker. Sometimes the sky can even be pink or purple. And then we have beautiful oranges, but if we also see brown, and the brown might look like horizontal lines or vertical lines or speckles. Let's go to the next slide. And sometimes we see winter in the desert, so we get white mixed in with those greens and oranges. Or also we can see beautiful wildflowers as well. So I always have students look at these photos that we're going to use before we start the project and say, what colors do we see? Okay, next slide. And again, golds, browns, blues, whites. Okay, next slide. I think now I'm going to ask you to join with me, and I'm going to do this pretty quickly because I know that we're a little bit behind schedule. So right here, you can see my paper. For this project, if you are using your own paints from home, I just like to use a plain paper and imagine the color that I want to recreate from a landscape. So I'm using um, acrylic paint here. You're welcome to use acrylic or tempera. I just really like the vibrant colors that I get with acrylic. And with this, I would set up maybe um, do this project with your students and let each table, if the students are working in tables, let them all do the same colors at those tables, but have their own pieces of paper that they'll be making and then set them aside to dry. And then the next week come back and share the papers with the whole class. And so you made greens, we made oranges, but we're all sharing. So I just squirted out a few colors, some tan, some brown, some orange, and we're just using a paper towel here. It's really just sort of some glorified finger painting, but I have students smear and smudge the colors around. And this is so fun. And right there, that could be it. I could be done. I want to see lines in my work. I want to see smudges and smears. And even if you have a lot of paint, you can have a student take another piece and set it on top and wipe it and then pull it up. And then this is a great start, and I can maybe put another color over the top of this. Maybe I add tan to this or green to this. So the painting, there's nothing special, but the idea is to have students work together in one class period to just make a variety of colors that you can use later. So here are a few others that I've made. This is brown with blue. Um, don't disregard really bright colors. Sometimes we have a shadow that's purple or a beautiful color in the night sky. Golds, browns. We're looking for kind of ugly papers with a lot of texture. I'm not flickering, like flicking paint or splattering, but just smudging it around with a paper towel. So if you want to work on this in the background, do that while we're going on to the rest of our presentation. Let's go to the next slide. Okay, while we're working, we are going to have you sharing the art that you make with us. So this slide has a QR code and a link to our Padlet. We've done this in the past. It's just kind of a pin board where you can put images of what you're creating. So if you add anything to this throughout the night, we'll look at it at the end. So if we go to the next slide, again, it's the same QR code and the link. But I have quick instructions. You can scan the code with your phone or add the link. And then when you press that plus sign that's the bottom center, you'll be prompted to add a subject and a comment and upload your image and then hit submit. And the nice thing about Padlet is you don't have to have an account. You don't have to be signed in. You just submit your work. Thanks. Next slide.
Thanks so much, Elisa. Um, Next, I'm going to invite Jackie to speak with us about Utah's desert habitats.
Hi, everyone. I'm Dr. Jackie Grant, and I used to teach at Southern Utah University, and now I work at Grand Staircase Escalante Partners. So next slide, please. We will go through the outline for the presentation today. I'll start with some introductions about me. I'll talk about my organization, GSEP, or Grand Staircase Escalante Partners. And then we'll talk about Utah's deserts and some secrets of the deserts that are provided or caused by geology, wind, and water. We'll talk about an example of plants and how they're adapted to desert life, as well as animals. And remember to write down your questions for the end of the webinar today, when we will have some time for questions. Next slide. Okay, so who am I? A whole lot of things there. I'm not going to read them all off, but I've done a lot of things in my life, and my husband has called me an ADD scientist, so that tells you how old I am that I use that term instead of other terms that are used. But in my past, I got a bachelor's degree in biochemistry from Texas A&M, two separate degrees from Cornell University, where I studied rhinos and caterpillars and chemical ecology and nutritional toxicology and population genetics. I went on to do a conservation postdoc at Smith Fellows. I worked as a wildlife and fisheries scientist at Michigan Tech and Penn State, and finally ended up at Southern Utah University in 2011, where I was able to partner with many different groups spanning from the Paiute Indian tribe of Utah through several different federal agencies that you can see their logos on the bottom of the slide. And in 2023, I was lucky enough to be selected as a Fulbright Scholar to New Zealand, where I studied the intersection between Western science and Indigenous seed collection practices with the Maori people of New Zealand, and came back from the Fulbright and had a change of heart about life and applied to become the executive director of Grand Staircase Escalante Partners, which is where I am today. Next slide, please. Okay, so what is Grand Staircase Escalante Partners? We are a 501c3 nonprofit, which means that we have a certain tax status. That's pretty much all that means. And our mission is to honor the past and safeguard the future of the Grand Staircase Escalante National Monument, which is part of a big desert in southern Utah, and the connected landscapes and watersheds of this area by using science, conservation, and education. Next slide, please. All right. Our national monument that we are Friends Group for, the Grand Staircase Escalante, is part of the Bureau of Land Management's, so BLM, its National Conservation Land System, which is a system of over 300 different pieces of land managed by the Bureau of Land Management. And almost all of them have a friends group, nonprofit associated with them to help them out to do the things that the Bureau of Land Management cannot do. So let's do the next click, please. And the BLM, because it's a federal agency, you can imagine has a definition of what it means to be a friends group. But essentially, it's a nonprofit organization, usually formed by volunteers. And those volunteers, which eventually become paid employees of the nonprofit, not of the government, assist and support the Bureau of Land Management with its site. For us, the site is the Grand Staircase Escalante National Monument, or a specific facility. It could be a lighthouse in Florida, or a program like an educational outreach program. And these friends groups vary in their size, structure, and their purpose. Our friends group is about 10 employees right now, but some friends groups are dozens of employees in size. And what do we do? On the picture on the right, you can see we fundraise for the monument. We do stewardship activities, so we bring volunteers out to clean up trash. We do restoration by taking down invasive plants in the desert to help the rivers flow more freely. We do educational outreach programs. We work with all the tribes that have a connection to the Grand Staircase, and we do science and research. Next slide, please. All right, now we get to talk about deserts. So what is a desert? One definition of a desert is that it is a biological community in which most of the native plants and animals are adapted to almost constant dryness and occasionally extreme droughts. So they're actually adapted to deal with these extreme droughts like we're experiencing now in Utah. And these conditions are necessary to maintain the community's identity as a desert. So if you take an animal or a plant out of the desert and give it extra water, it actually won't do well because it is adapted to dryness. physiologically, so that means the processes of the body are there to help it survive in the desert, and it will not do well if you give it too much water or extra water. We can see in this picture on the right-hand side of your screen that one, there's moisture in the air over this particular desert, but we also see lots of green because these plants are adapted to that extreme dryness of the desert. So they live there, they're meant to live there, and it's only in very rare circumstances that we'll talk about a little bit later where there's just absolutely no vegetation at all. Next slide, please. Okay, Utah is home to three main deserts of our North American deserts. We call these arid lands. And I would like to remind you all, I am a scientist, and so there is going to be a fair amount of vocabulary in this presentation. And I've tried to highlight the vocabulary in red so that we can remember what those words are and that scientists have their own language. And when we start talking about science, sometimes we have to switch our mindset into the language of scientists. So arid means dry, and deserts can be called arid lands or dry lands. In Utah, we have those three main deserts. So the first is the Mojave Desert, which is an arid, warm desert. And that just means it gets hot. It rarely snows in the Mojave, and we only have a little bit of it in Utah, down by St. George in that southwest corner of the state. Then we have the Great Basin Desert, which is on the western side of the state and mostly over into Nevada. And that is an arid, cold desert. So it snows in that desert. The Colorado Plateau, which is on the eastern side of Utah, is sometimes considered to be part of the Great Basin Desert, but it's really a very different place because the Colorado Plateau has mechanisms for the water to flow out of the Colorado Plateau and into the Colorado River. Colorado Plateau is also a semi-arid and cold desert. So it only gets about 12 inches of rain per year, but that's kind of wet for a desert. The arid deserts, the Mojave and the Great Basin, they usually get 10 inches or less. This particular map came from a research paper from a group that was studying ant lions, which is this creature that you see on the right. So some animals and plants are adapted to their specific desert, and other animals are adapted to most deserts in the region. So this antlion, we can see from the little dots on the map, black and white dots, this antlion is adapted to all the deserts of the United States. So the Great Basin, the Mojave, the Colorado Plateau, and the Sonoran Desert, which is down in the southern part of California and Arizona. Next slide, please. All right, some of Utah's deserts have very special areas within the desert as a whole. So up in the northern part of the state, we could consider the Bonneville Salt Flats as part of the desert because that's an area where there used to be water and the water has dried up, as most of the folks up in the Wasatch Front know. The Sevier Desert is more towards the middle of the state and it formed in a similar way. The dry Lake Sevier is the main feature of that desert. And both of those deserts are part of the Great Basin Desert. Then Red Cliffs National Conservation Area is down in the Mojave Desert by St. George, and it is a warm desert. So it's very different from those two northern deserts. And it is home to our state reptile, the Gila monster, which is a big red and black lizard. And it is also one of the only places in the state where you're going to see a Mojave Desert tortoise. Our other two deserts here, D and E, Coral Pink Sand Dunes and the Grand Staircase Escalante National Monument, are all part of the Colorado Plateau Desert System. And this picture that you can see on the slide shows a desert-adapted plant, Welsh's milkweed, that we'll talk about in a minute, that lives in coral pink sand dunes, which are sand dunes that are formed because of how the wind blows through the environment. But we'll talk about that in a minute too. Next slide, please. Okay, so how do deserts form? What happens first is that warm water rises from the ocean or a large body of water. And as that water evaporates from the ocean and rises, it cools. And when we have a mountain range near the ocean, which we do here in the United States, we have the California Sierras, those mountains catch that warm rising air, cool it off because as it gets to higher elevations, it's colder. And then the rain drops out of the clouds as they hit the mountains because of that cold temperature. It causes the water to condense and then drop. And then on the other side of the mountains, so for us on the eastern side of the mountains, which is going to be Nevada and Utah, we see a rain shadow because just like a physical object blocks light from the sun, the mountains block the water from falling east on the eastern side of the mountains, which is Utah. So what happens now is that all the water is out of the air and we have cold air. The cold air drops as it comes down the mountain, and as it comes down the mountain, it gets warm and creates winds which dry out that desert environment even further. And winds are really important in the formation of deserts. Next slide, please. Winds and geology, they both shape the desert. So depending on what's on the ground, where the desert forms, you're going to get different types of deserts. So this is the Little Sahara Recreation Area, and it's managed by, again, by the Bureau of Land Management, or BLM, and it has a sand-based and a sandstone environment around it. So it forms sand dunes in this area. But we can also have deserts where the underlying surface is clay, and that's going to result in a muddy desert when it rains, or rocks, and we can have rocky deserts, and we have all of those in Utah. Next slide, please. So we'll go through the Grand Staircase Escalante National Monument as an example because it's one of my favorite places. And when we look at deserts and we look at the rocks, we can see this history of water hidden right in front of us. So if we look at the left-hand picture, we see pink cliffs, similar to what you see in Bryce Canyon National Park. This is a rocky desert because this area was formed when it was covered in water that was full of calcium carbonate. And that calcium carbonate turns into limestone rocks. So when you look at that desert, you see those pink and white striped rocks, like you might have seen over at Bryce Canyon National Park. And this whole area, even though it's a desert, is formed by water in the past and is now a very rocky desert. On the right-hand side of the picture, we see the Chinle Formation, which is a clay formation because this area, when it formed, was underwater, under a swamp that dried and then got wet again, and then it dried and got wet again. And each time it dried, the soil and the dirt particles were a little bit different because they had come from a slightly different area. And that's why we see those beautiful stripes in the Chinle Formation in Grand Staircase. This area is known for being very dangerous when wet because that clay turns into a really nasty mud. Next slide, please. All right, the central section of the Grand Staircase Escalante National Monument is the Kaiparowits Plateau section. Not as colorful, but still quite beautiful in a subtle way. And what we see here are lots of different types of grays and gray-blue colors. This also is an area full of clay from ancient swamps, so you don't want to go there during a rainstorm. And just as a reminder, the Grand Staircase Escalante National Monument is almost 2 million acres in size, and that's why we see such extremely different habitats. Even though it's all desert and it's all on the Colorado Plateau, it still is very different from place to place. But one of the great things about the Kaiparowits Plateau is that the swamps there were very productive for dinosaurs. So dinosaur fossils are being uncovered all the time from this Kaiparowits Plateau section of the National Monument. Next slide, please. And then finally, you might not have thought this, but the eastern side of the Grand Staircase Escalante National Monument, which is the Escalante Canyon section, is actually quite full of water. The Escalante River runs through here, and several other rivers that are intermittent, which means that they only flow at certain times of the year, come through this area. And between wind and water in the sandstone substrate, we get these beautiful slot canyons and very artistic and sinuous curves in the stone. Wind helps create sandstone, and it also helps sculpt the sandstone in these very smooth, curvy lines that you see. So it's a combination of water and wind together that create this area and make the beautiful slot canyons. And we call this process where wind sculpts canyons and shapes them Aeolian, after the Greek god Aeolus, who was the god of wind and blowing things around. So next slide, please. All right, now we get to talk about plants and animals and how they might specialize to live in deserts. The very first organisms to arrive in a desert are diatoms. Diatoms are single-celled organisms and they can settle down on that bare soil. So remember, the wind blows through and it blows away all the organic matter and all the topsoil, and there's not much left for a plant to grow on, and there's not much left for a seed to take hold in. So these diatoms arrive first and they're single celled. They pair up with cyanobacteria, also single celled, and both of which are photosynthetic, which means that they can get their energy from the sun and reproduce and create a biofilm, so a little film over the sand that then it is able to attract fungi and grow more and grow thicker. And then the fungi combined with the diatoms and the cyanobacteria can produce a habitat that is suitable for lichens and mosses to grow. And that combination of diatoms, cyanobacteria, fungi, lichens, and mosses is what we call biocrust. And you can see in picture A here, the biocrust is sort of this black, nasty looking area, and B is a close up of that area. But what you come to find out is without that biocrust and without those diatoms who got there first, we wouldn't have the desert plant life and animals as we know it because we need those microscopic organisms to hold the soil in place and create the foundation of the habitat for all the other animals and plants that live in the desert. So one thing you might often hear is don't bust the crust. And that means don't walk on crust when you see it because it is so important in its role in maintaining the desert habitats and animals and plants. Next slide. Okay, some examples. Because these animals are specialists to the desert. So again, this is that Welsh's milkweed, Asclepias welshii, named after a botanist whose name was Stan Welsh. And this plant shows adaptations of having water-saving abilities. So for example, you might notice on these pictures, the leaves are very fuzzy, and the plant actually produces these fuzzy plant hairs. They're not real hairs like we have in humans, in mammals. They're just a plant hair. And those plant hairs create a little barrier around the leaf that help the plant keep the wind from pulling all the water off the plant. So if you've seen a milkweed in a swampy area, it has very smooth leaves, but these desert milkweeds are fuzzy to keep their water to themselves and protect it from the wind. We often will see that these plants have smaller leaves than plants that grow in forests because a smaller leaf is just less area for the plant to lose water from. Another thing that we see in this particular species is that it has bigger seeds. So this plant grows again in coral pink sand dunes, and it's very windy there. That's how the sand dunes formed. And this milkweed has bigger seeds relative to all the other milkweeds because it actually needs its seeds to stay on the sand dunes. And if it had smaller seeds with a big puffy thing on it, then those seeds would blow away. And then this plant also has very deep, deep roots to reach way down through the sand to get to the water in the water table below, where the bedrock is underneath the sand dunes. Next slide. Another example in the animal kingdom is Ord's kangaroo rat, Dipotamus ordii. And so this little kangaroo rat is what we call a zircole. And that just means it's adapted to the desert and dryness. So XER means dry. You might have heard the term xeriscaping. It's not xeroscaping, it's xeriscaping because xer means dry. And the zircoles are adapted to this desert lifestyle. And in fact, the kangaroo rat does not drink water from little puddles or anything like that at all. It gets metabolic water from seeds. So it eats the seeds and actually can strip water off of fat molecules. And that's how it gets its water. This animal also comes out at dusk or at night, and we call that nocturnal. So nocturnal animals come out at night to stay cool. And this animal also spends the daytime underground, and we call that semi-fossorial because semi means partly or halfway, and fossorial means underground. So these semi-fossorial animals don't spend all of their time underground. just during the daytime, and then they come out and they spend a lot of time above ground looking for seeds at night. Next slide. Okay, so to conclude, wind, water, and geology shape the deserts, as we can see in this beautiful picture here of a prince's plume plant in the desert, looking at some Kayenta sandstone. And then the microbes, plants, and animals, they all specialize to live there. So don't try to take them out of the desert. They need to live in the desert. And then the deserts themselves are these communities built and maintained by dryness, and all those organisms have adaptations for dryness, which together creates a desert. Next slide. All right. Or if you have a dog who loves the desert, like my dog Cleo here, I would love to have you join our group and get your pet recognized as a desert-loving animal, even though they might not be desert adapted. And next slide. If you have any questions, remember to write them down, and we'll have time to answer them at the end. Thank you so much.
Jackie, thank you so much. That was great. I learned a lot. Now we have a video for you where I'll create a simple rabbit puppet. Hello, my name is Tamara Goldbogen, and I'm the director of the Arts Learning Collaborative at Weber State University. I'm back with another knotted fleece puppet. In past webinars, we have made rod puppets of the bee and also a brine shrimp puppet. You can always visit the Arts Learning Collaborative's YouTube page for recordings of our past webinars. For this webinar, I've been learning a lot about the jackrabbit found in Utah deserts. Utah jackrabbits are one of the amazing secrets of our desert habitats. You can spot them during early morning and twilight hours when they are most active. One of the most interesting adaptations of the jackrabbit is its ears. The jackrabbit's ears are 6 to 7 inches long. Their ears are like personal air conditioners, and they're packed with blood vessels that release excess body heat, helping the jackrabbits to stay cool in the desert heat. Today, I will show you how to make a simple rabbit finger puppet, like this one. You will need a piece of fleece that's 3 inches wide by 22 inches long, with the ends rounded to make the ears. You can use a variety of fleece colors, depending on what type of jackrabbit you want to create. There are 2 types found in Utah: the white-tailed jackrabbit that stays grayish-brown in the summer, but turns almost completely white during the winter to hide in the snow. The black-tailed jackrabbit stays brownish-gray all year and is easily recognized by its massive black-tipped ears. You'll also need 2 googly eyes and a small triangle of fleece that's going to be the nose for a rabbit puppet. You'll also need an adhesive. To make the rabbit, you'll fold the piece of fleece in half, lengthwise, or hot dog style, like this. And then you're going to fold the fleece in half again, this time bringing the rounded edges together, or hamburger style. Like that. Next, you're going to tie a knot at the folded end, like this, and this is going to be the head of your rabbit. Take a second to adjust the ears and the knot to make sure you like the way the head of your rabbit looks. You also want to make sure there's space for your finger, since this is a finger puppet. 2 great things about knotted fleece puppets are that you get to practice making knots, and if you don't like your knot, you can undo it and try it again. Once you have the head and the ears of your rabbit looking good, you can add googly eyes. I'm using a drop of Fabri-Tac, which is a fast-drying adhesive. However, if you're working with younger students, you'll want to use a non-toxic adhesive, such as white glue or even glue dots. Another option is to use a black Sharpie to draw the eyes and nose directly on the fleece. You could use a Sharpie to color the tips of the ears if you are creating a black-tailed jackrabbit. Finally, I will add the tiny triangle of fleece that will become our rabbit's nose. Congratulations, you have just created a rabbit finger puppet. If you want to learn more through a story, you could check out How Jackrabbit Got His Very Long Ears by Heather Urbankus and Kenneth Spengler. This folktale introduces desert animals, jackrabbits, tortoises, bobcats, and roadrunners, and their adaptations, making it perfect for learning about Utah's desert habitats. There are also many fun ways for your students to activate their puppets. One of my favorite ways to use puppets in the classroom is to have students create a puppet show with the puppets that they make. First, students create characters for the puppets. I've included a character sheet in the webinar resources. The character sheet has a few simple questions to help your students use their imaginations to name and create a character for their puppets. Students work in small groups to create and perform a short puppet show where one of the puppets faces their greatest fear. All the puppets work together to find a peaceful solution. I love to have the students incorporate relevant vocabulary into their puppet shows. I've included some jackrabbit facts and vocabulary in the webinar resources. I ask students to incorporate at least 3 vocabulary words into their puppet shows. If you want to see a puppet show about another famous rabbit, Peter Rabbit, you can watch the Arts Learning Collaborative's production of The Tale of Peter Rabbit. I'll include a link in the resources. Thank you so much for making puppets with me today. I hope you have fun using puppets as a teaching tool in your classroom. Great. Let's welcome back Jackie, and she's going to share some desert secrets about jackrabbits and also the wind in the desert habitats.
All right. So jackrabbits are definitely adapted to living in the desert. And they're one of those animals that live in many different types of deserts. They have those blood vessels in their ears, which you can see pretty well in this particular photo. And those blood vessels help move the blood that carries heat from the core of the rabbit's body into the ears, where then it can be dissipated into the environment. So these ears are big surface areas. The bigger the surface area you have, the more heat that you can lose very quickly. The rabbit, however, does live in those cold deserts. So when it's cold, the rabbit's blood vessels will shrink and you will hardly be able to see them at all. So we call this vasodilation. And vasodilation is just when the blood vessels expand and then they will contract when the rabbit is cold. And it helps the rabbit cool down without losing moisture. So if you think about your dog in the desert, your dog pants and its nose is wet and it loses heat as the water evaporates off of its tongue and out of its nose. But for a rabbit, it doesn't want to lose the water because it lives in the desert. So it uses that vasodilation to cool down. And the wind transports the heat away from the ears. Next slide. And again, that wind helps the animals and it shapes the desert. In this particular picture on the right, you can see the coral pink sand dunes with the sand blowing off the top of the sand dune itself. And as that sand blows, that is that aeolian or wind-driven process that shapes the dunes and shapes the desert. And in this case, in coral pink sand dunes, the wind comes whistling through a notch in the mountains on the south side of the dunes. And that wind carries the sand, it scours it off the mountains and then drops it onto the dunes. And that is the aeolian process visible every time you go down there. Now, we also know that the sand dunes don't always just have sand on them. The sand dunes will have something called Thermophilus. So it starts with a P, but it sounds like an S. Sand-loving plants. So Thermophilus plants hold the sand in place against the force of the wind. So it's a constant battle between the wind and the plants. These Thermophilus plants are dune stabilizers, and humans and animals rely on dune stabilizers for several different reasons. For animals, the dune stabilizing plants keep the sand dunes in place and provide habitat for the animals to live in. And for humans, especially on the coastal part of the world, wherever there are sand dunes, we want to keep those sand dunes in place so that the coast doesn't erode away into the ocean and so that the sand dunes don't go over the road and cover it or cover a house or part of your yard with sand if you happen to live near a sand dune. So these Thermophilus plants are really important for sand dune ecosystems and the humans who live around them. And it's always important to remember that if you step or drive on these dune stabilizing plants, it can really negatively impact the habitat. It can kill the small little tiny animals that live there or wreck their homes and destabilize those dunes, which will cause problems for other humans who might live there and obviously the animals and plants. And that was all I had to say on the rabbits and the dunes.
Great, thanks again. Now we have a music video connecting to a song about wind.
Hello, I'm Samantha Steffen, BTS Arts Program Coordinator at Weber State University in the Arts Learning Collaborative. Today we're going to connect music with Utah's desert habitats. When I think of Utah's deserts, whether I'm thinking of the Mighty Five regions in the south, the Great Salt Lake Desert in the west, or any desert in between, one thing that's almost always present is the wind. The wind affects desert life and landscapes through weather patterns and erosion, and it's a major part of how Earth's systems interact in desert habitats. One of my favorite songs to use in elementary music class is called Who Has Seen the Wind, and it usually ends up being one of my students' favorite songs too. It's short, it's simple, it has a beautiful melody. The text is adapted from the poem Who Has Seen the Wind by Christina Rossetti. We're going to explore 3 activities you can do with this song to connect what students are learning in science and ELA with the music standards. Our first activity centers around how you introduce this song to your students for the first time. You might say, I have a new song for you today. Before I tell you the title or sing the words, I want you to listen to the melody, and then play the melody a couple of times on an instrument. This song fits well on a xylophone, but I really love how it sounds on a recorder. After playing the melody, I'd ask students to sing it with me on a neutral syllable like lu or la. Then I might say, I'm going to play it 3 more times. This time I want you to think about what the words might be about. What topic might match this music? You can think of a couple ideas if you have more than one, but keep them to yourself. You can decide how you want your students to respond. I like to ask students to write down their ideas on a slip of paper or a sticky note before sharing with a neighbor or the class. Collecting a short written idea lets me get a response from every student, even those who don't like to share in front of their peers. And it helps me to get students' individual ideas before they hear what others have to say. Then you can have students share their ideas and what makes them say that, but don't reveal the correct answer yet. It can be fun to end on a cliffhanger where you tell your students they'll have to wait till next music class to find out. The next class period, review the melody and have students remind each other of their guesses. Then you can sing the song with the words. Who has seen the wind? Neither I nor you. When the leaves bow down their heads, the wind is passing through. Ask students to identify the correct answer, that the song is about the wind. Finally, you can reveal the title and have students sing the song with the words. Once students know the song, it's a great opportunity to explore the text through your grade level ELA standards. Maybe your class is exploring poetry for National Poetry Month in April. Maybe your students are learning about metaphors. Maybe your class is learning about the conjunction neither nor. You can ask questions like, what are ways we can see the wind? And what does it mean for the leaves to bow down their heads? Are they really bowing, or does that mean something else? If you want to look at the original poem too, students can compare and contrast the words of the poem with the words of the song. There are really lovely little jewels to find in both the adapted text of the song and the original Christina Rossetti poem. Second, you can use this song for melody activities. If you're teaching melody using solfege, this is a wonderful song for teaching low la. It only uses 4 notes, 6 of the La pentatonic scale, and it's in AAB form, so the song is simple enough to really focus on low la as a new melody note. If you set this song in the key of E minor, where la is the note E, it fits well in students' voices, on a xylophone, on the recorder, and on the staff, so you can use your favorite strategies for teaching melody. Low la is a skip below do, so you might even use your rabbit puppet to help illustrate that skip. Finally, because this song is so friendly for instruments and voices, it's a great choice for arranging activities. In music, an arrangement is a new version of music that already existed, similar to when writers adapt a novel into a screenplay. A common example of this is when a composer writes a new version of a traditional folk song or hymn. They're creative with their use of instruments, voices, harmonies, introductions, interludes, endings, tempos, mood, and so on. But the core remains the same, and it's still recognizable as the original song. Arranging is a great entry point for students to create their own music because they aren't starting from scratch. Leading an arranging activity in your class can be as simple or as complex as you want it to be. Your students can create arrangements individually, in small groups, or as a whole class. My preference is to have students create on their own or in small groups first, and then suggest ideas for a whole class arrangement to make sure students can be involved even if their idea doesn't get chosen for the full group. You can give your students choices of instruments that resemble wind, like wind chimes, finger cymbals, sand blocks, or shakers. Students can learn to play the melody on recorders or xylophones, and you can create simple ostinatos for additional xylophones or non-pitched percussion instruments. Once students can play all these parts, they can decide what sections to include, what order they should come in, and how many times to do each one, and then even make other musical decisions, such as how to add dynamics. Then they perform for the class. Here's an example of an arrangement that I made. In my introduction, I layer sand blocks, shakers, and wind chimes in that order 8 beats at a time. Then those instruments keep going while we add recorders playing the melody once. After that, we sing the song 2 times. The xylophones are going to layer in with a bass ostinato, an alto ostinato, and finally the melody. And then we'll sing the song 2 more times before an outro that's the opposite of the intro. Arranging is so flexible that you can design this activity to meet your students where they are, and you can add in limitations or requirements to fit your students, situations, and learning objectives. I like to add a piece where students tell me why they chose what they did. Student arrangements are also great to include in performances, however you share those with your school community. Thanks for exploring some musical strategies with me today. I hope you have some ideas for including this beautiful, simple song into your classroom and that your students love it too.
Great. I will now invite Erin and Olivia to lead us in a scratch art activity that feature diatoms. Just a reminder, we are putting all of the supplies that you'll need for this part of the webinar into the chat.
Okay, so we're going to talk a little bit more about what is a diatom. And just like Jackie said, they are single-celled organisms that are incredibly tiny and they're classified as a type of algae. Diatoms are an incredibly important part of the Earth's ecosystem. They generate about 20 to 50% of the oxygen produced on the planet each year. They come in a variety of shapes and sizes. There's about 12,000 species that have been documented, but scientists estimate that there could be over 2 million species total. Next slide. So what do diatoms look like? So they share similarities between themselves, but also come in a variety of shapes, as you can see in the photos. Each diatom is surrounded by a cell wall, which is called a frustule, that is made of silica, which is the main component of glass. And this is why they are also known as the jewels of the sea or living opals. They're incredibly small, the largest being about the width of a single hair. So I am going to transition over to my webcam. And while I'm doing that, make sure you have your supplies, specifically your paper, your diatom reference sheet, and your crayons. Okay, so all of the diatoms have the cell wall, but there are two categories that you can split diatoms into. The first are centric, and centric ones are radially symmetrical, which means they can be split into multiple symmetrical pieces from a central point. So here we have one of our centric diatoms, and I can cut it up into little pizza shapes, and they're all going to be symmetrical around that central point. And these ones are usually not mobile. They do move with their environment, and they are more common in marine environments. The second type are the pinnate, and these ones are bilaterally symmetrical, and they can be split lengthwise into mirror image halves. They tend to have a more elongated appearance. So if I were to cut this one in half, each side would be mirror image of itself. So, next slide. So I want us to keep those things in mind as we move on to drawing our diatoms. So I have with me a 4x6 piece of paper and my crayons. And I am going to begin drawing my diatoms onto my piece of paper. And this is going to be the beginning part of our scratch paper. So I've created a reference sheet that you have access to where I've looked at a bunch of different diatoms and kind of simplified the shapes. You can see centric ones, pinnate ones, a wide variety, and you can use this when you are drawing your own scratch art piece as a reference. I figure if you draw one that doesn't actually exist, maybe it's one of the ones scientists haven't documented yet. So I'm going to start by drawing a centric one. And you want to make sure that you're applying a decent amount of pressure. Sorry, let me refocus. With your crayon so that you are covering as much white space as possible. Okay, sorry about that. We're refocused. And I'm just going to copy some of the ones that I have on my reference sheet. And we are going to be working on this as Jackie talks a little bit more about diatoms. And we're going to try to get to this point where we've covered our sheet with a wide variety of colorful, various size, different types of diatoms. And when we are finished with that part, we are going to cover the background with brown, again with the crayons. So I'm going to turn my time over to Jackie to talk a little bit more about diatoms, and I'm going to continue to work on my scratch art paper with you guys.
Great. Great introduction to the diatoms. So as Olivia said, diatoms can live on land and they can live on water. And if you've ever seen like the Great White Cliffs of Dover, those are well, those are actually another kind of microorganism, but very similar. Very tiny organisms that will grow by the millions and billions and trillions and can actually form geologic structures. But how do diatoms survive in the desert? Well, it turns out in the desert, where there isn't a lot of water, they live in something called a biofilm. And a biofilm is just a slimy covering. In the desert, it's very, very thin. You have a biofilm in your mouth, you have a biofilm in your nose. There are biofilms on trees and on rocks that are in the water and on rocks that are not in the water. Biofilms are everywhere, and they're made up of small single-celled organisms, and not necessarily all diatoms, but this covering that covers lots of things on Earth and things inside our bodies as well. So the diatoms can survive when it gets really, really dry by creating something called a resting spore. And this is just an extra strong silicified covering. And silicified means it's covered in sand and silica. And silica is the primary ingredient to sand. So when the frustrule is made of silica, so it's quite heavy, and the resting spore is like a frustrule on steroids. It's very, very thick. And once inside this resting spore, the diatom slows its metabolism down to almost nothing. And they can actually survive as individuals for thousands of years in this slow metabolic state until they get water again. And again, that external covering called the frustrule protects them from the external harsh desert environment, and they respond very quickly to water once it comes. They reproduce mostly by asexual binary fission, which just means they split in half all by themselves, and one diatom turns into two diatoms. There are some very special cases where there is sexual reproduction, but for the most part, they just split in half when the resources have been good enough for them to move on to the next stage and make more diatoms. Next slide. Okay, so these special structures, again, we've talked about the frustrating frustrule, that's kind of hard to say. That is that silicified external covering of the diatom, and it's transparent. It lets light in so that the diatom can use its internal chlorophyll, which is a chemical structure that lets them produce oxygen. And 20 to 30% of the Earth's oxygen, or maybe more, is because of diatoms. So if you think about that, every fifth breath you take would be a breath of oxygen from a diatom. The diatoms in some situations can be mobile, right? Those pennate diatoms that are living in biofilms. And the way that they move is they secrete mucus, so a little bit of slime in their slimy biofilm, from a structure called the raphe or the raphe, and either pronunciation is fine. But that raphe is that long slit down the middle where they can squeeze out the mucus and then slide along it like a snail. And a raphe is any place where two things come together, and then it could secrete mucus, it might not. But in the diatom, it's where the two sides of the frustrule come together. But if you feel with your tongue on the roof of your mouth, you might have a physical raphe there that formed as you were an embryo, and your mouth formed, two sides of your jaw came together. And some people can feel that joining of the two sides of their mouth on the roof of their mouth. So that's an example of a similar structure that you have that a diatom also has. The diatoms can float when they live in water by using a pump, an internal chemical pump, to move heavy ions like sulfates and magnesium and calcium out of their bodies, out of their cells, and then replace them with lighter weight ions like sodium that's in salt, or potassium, like potassium in a banana. Those weigh less. And when the diatom pumps those in and out of its system, it can regulate where it is in the water column. Your desert diatoms don't have to do that because they don't live in the water. They just squirm around on the biofilm and grab onto grains of sand in the desert to help build that biocrust. Okay, I could talk a lot more about diatoms, but that's what I put together for today. Hopefully you all made progress.
Okay, so I'm going to show you the next step to making your scratch paper. So I'm going to switch out. So remember, we want to draw our diatoms and cover our piece of paper and then fill in the remaining white space with a brown crayon. And crayons work a lot better than oil pastels. I did some experiments, so I would always recommend using crayons over oil pastels. So now that we finished our diatom sheet, we are going to paint the top and cover it with our biocrust. So you're going to take your brown paint and then your dish soap, and you're going to mix about equal parts of both. And this is what you're going to be using to cover your sheet. Got a little bit of dish soap. So I'll mix that up. You're going to have to do about 3 layers of paint to completely cover all of your diatoms. And I like to use a foam brush because it spreads a lot more easier and cleaner. Just using long strokes. Then wait about, I would say, 20 minutes in between each layer to add the next layer. But you can see that even though we've covered some of our diatoms, they are still showing through just with this first layer. So once you finish all of the layers, it will look more like this and be completely covered. And then you want to be able to wait about overnight to have it completely dry. It might seem dry after a while, but it will pick up on your fingers. So wait about overnight before you move on to the next activity. So I'm going to turn my time over to Erin, and she's going to explain the next activity that you'll be able to do with your scratch paper.
Hello, everybody. I hope you have enjoyed learning about these fascinating and amazing single-celled organisms, the diatoms. So you're probably wondering, oh, here we go. My students have created these beautiful, colorful, organic and geometric shapes filled with patterns and colors, and now we've covered them in kind of this poopy brown. What are we going to do about it? Well, I'm going to quickly tell you about how you can take this art project and turn it into an activity in your classroom where your students will become scientists out in the Utah desert in search of hidden diatoms. So once you have your diatoms covered in the biocrust, your scratch art is ready to go. You're going to invite your students to exchange. So they'll pass around. You can make it fun where maybe you gather them and then repass them out. And so they are going to receive their own biocrust section that they don't know what's underneath. And as every good scientist keeps track of all their findings, I have put together what is a desert field guide to help them discover their hidden diatoms by highlighting 4 areas of focus. The objective is that the students are the scientists studying a sample of the desert biocrust. They're going to carefully scratch away the surface to reveal the hidden diatoms beneath. They are going to observe. Oh, sorry. There we go. They're going to observe. They're going to look with their eyes to see what they discover, and they are going to respond to the following prompts, such as, what shapes do you see? Circles, ovals, triangles, rectangles, or other shapes? It actually even asks them as they uncover the diatoms under the biocrust, which one of them is the most interesting to you, and sketch it out in this space. The field guide goes on for them to analyze, to think like a scientist. It asks them, what kind of symmetry are you observing? That radial, that bilateral, maybe you see that there's evidence of both, or maybe none at all. It continues on until we get to the connect, where it's understanding the biocrust. And in these 3 questions, we ask about the biocrust. We are having students apply their knowledge and understanding of what they have learned about diatoms in their analysis and response. And finally, we have the reflect, where we're actually taking the science and we are connecting it with the arts, where it says, what surprised you most about your discovery? It even asks, how are science and art connected in this particular investigation? And then a fun part of this is giving the students the opportunity. If you could name that one interesting diatom you'd uncovered, what would you call it and why? So they're going to take this field guide with them. They're out in the desert. They have their sample biocrust. Using a wooden stylus, they're going to use this tool to carefully scrape away that top layer, not doing it very hard. That liquid soap, that dish soap that you added to the paint really helps the paint come off easily, but it does take some time. But doing it carefully, they can move and scratch it out, wiping away the biocrust as they look for these diatoms. Now, here we go. This one, you guys can see that we have uncovered quite a few, carefully removing that top layer. As you can see, we have a variety of different diatom shapes, colors, and patterns that, as a scientist with my field guide, I can open this up and start to look at and respond to apply the knowledge that I already have about diatoms and the ones that I'm discovering, the information and the details that I am discovering as I'm exploring and uncovering these hidden diatoms. So I hope you and your students have a lot of fun with this activity, taking the information, the project, and turning it into this learning opportunity.
Thanks, Erin and Olivia. Now we're going to check back in with Elisa, where she's going to lead us in painted paper landscapes.
Awesome. Let's go ahead and go to the next slide. We have a short video. I'll turn off my sound. I would say move your slider to watch the video large.
Create a landscape collage. Select a landscape photo to use as a reference. Trace lines in the landscape. Choose papers to use in your project. Start with the sky. Glue as you go. Continue adding layers. Work from the top down. Add final details. Trim the edges. Enjoy your finished work of art. Nice job.
All right, so this is such a simple project, and I do have several kind of tips that I want to share with you for helping this work really well for students. Now, in your packet, the resources that we're using for this are on the left side of the folder. And you'll see some larger brown craft papers and some white papers, and we're going to put those aside. We may not have time to get to this project. It's for a little pop-up card, but there are instructions that you'll get by email to show about how to do that. But we're going to use these a little bit heavier cardboard pieces, and there are squares and rectangles of different sizes, and you're welcome to cut them as well and make the choice of what size you want to use. And I have a few examples here. In the packet that we sent home, I gave you some images of Utah deserts. You can see this one's been drawn on. You can use these or just look up pictures on your phone of Utah deserts, and you can see we'll be making our own little collages based on those images. So I want to get right to it. I'm going to use, oh, here we go. I'm going to use an image that actually my friend Elaine decided to use to take this piece. Instead of having it horizontal, she did it vertical. And so she just used this little part of this image to make this collage. So I decided I want to use this part of the image. And one thing I found when I'm working with children is if I say, just make a collage of this, they kind of don't know where to start. So as we saw in the video, it works really well to work from the sky at the very back and then move our way forward to the background to the foreground. And so I want to use this piece of paper as my sky, and I'm just going to estimate that's about a little more than halfway down. So I'm going to glue that down. You can see I put some scrap paper here to work as a mat for my glue. And I'm just going to use a glue stick and glue this piece down. Now, I like to trim everything up at the end, so I use things that are a little bit larger than my background, but I think it's important to trim the sky first because this can trick you. You think the sky goes all the way up to here, but really it's a little shorter. So I tell students, turn it to the back and trim it right along the edges. That really helps students. Um, Make sure that this paper covers the complete background. Otherwise, they're going to try to cut a piece out that will fit here and they'll just never be able to get it right. Okay, so now I have my sky in place. I need to start thinking about the shapes. And one thing I love about this project is it gets students to really look at the shapes of the land and figure out or start questioning, how was this formed? Why is it this shape? So I have students just find shapes that they can trace. I kind of want to do a line here. Maybe this comes down like this. I know it's kind of small, but I'm just thinking of shapes. Now I've got evidence of humans here with the road going through. Okay, so I think these are the things that I'm going to use for my landscape. And if, as I'm doing this, you're welcome absolutely to work on your own images. So I have a variety of oranges here. I love the darkness of this, so I want to use this for this little back part. But I love these stripes, so I want to use those for this area here. And I find that when kids draw on the picture, it gets the shape into their mind, and they can kind of freeform cut the paper. Now, I'm not going to be exactly perfect, but I kind of think I want this to go like this. I'm just going to cut along until I get the shape. Okay. So I think that'll go here. I don't need all of this, so I'm going to cut it off. I found when I used to do this kind of project with children is they wanted to start at the front and work backward, but I always want to go from the back to the front, and I can make this be longer than I need it to be, and then I can end up covering up that last little bit that's sitting down. Let's see. I want to do something like this. I also like to have students set their pieces in place before they glue anything down to make sure that they're really liking it. And I really like to think about what directions are my lines going? What are the patterns looking like? I'm going to do this little part here that's kind of a rocky area. And so I love this section. I think I'm just gonna get a piece like this. There we go. Okay, and now I have to make some choices because I don't really have the same colors. I don't have an orange with green in it. So I'm going to call this area here, all of this, just this green. I kind of like that. But I think I'm going to add a little bit of orange back in a second. So this could go here. Then I want to make my little road shape. Yeah, maybe like that. There's a road. And then I might add maybe a little bit more orange here in the front. That could be my shape. So that's my rough draft, and now I'll start gluing these pieces down one by one. It's my hope that you're working in the background and looking at my time. I'm actually not going to glue these down, but I'll do a little bit. Let me show you what I would say. Another problem students often have with this, one, if they draw with pencil and cut it out, there'll be pencil lines all over it. So I never have them draw. I just say, trace it here and cut it out freehand. And then another thing is they'll glue here and stick this down, and then this will be a mess. So I always say, glue the smaller piece, the back of the smaller piece, and then put it in place. That's another thing to really think about. And then finally, when it's all done, we'll turn it over and trim the back. So I'll show you this on the Padlet in a moment. But I did want to show you another option. This, as you saw in the video, I did this project as young as kindergarten. Really, really young children can do that. If you want to do something a little bit more advanced for older kids, you could turn that same project into a bit of a pop-up card. You can see here, I've got, this is 3-dimensional. And so this can close and then open again. And we don't have a ton of time, but I do want to show you that what I would do for that is on this project, you'll use the white pieces of paper, and I'll glue down my background and then the ground itself, any details I want there. And then I'll think about, I'm using this picture, think about any pieces that I want to have layered and cut those out. And then the final thing I'll do is make little tabs, and I've got them pre-cut here. Fold this in half and cut some tabs. Again, there's a handout that you'll receive by email that shows how to do this. And then I can push those tabs forward. And that is what I'll glue my little pieces onto. So this piece would go here. This piece would go here. And have another piece here. The one thing you've got to really think about is if I put a piece that sticks out that covers the whole thing, then I couldn't have a tab in front of that. So you may have to think about what's going to come first, second, third. You may put some background pieces that are glued directly onto the background. But I'll finish this up and the other piece I was working on, and I'll put them into the Padlet, and I'll invite you to do the same. This is a simple project. I hope you really enjoy it. And as you do it, think about the lines that you see in the landscape and the shapes and how it makes you think about how were these landforms formed. Thanks. I think I'll go ahead and turn the time back to our next presenter.
Thanks so much, Elisa. I can't wait to see what everybody's creating. Next, we have a video from Deja where she'll lead us in exploring desert blooms.
The desert can look so vast and barren. It can be a harsh environment. Bleached dunes rippling, windswept, cracked earth under intense heat. But beneath the soil, seeds lie waiting patiently, sometimes for many years, until just the right conditions occur. Just the right amount of rainfall or wildfire smoke. And then, beneath the soil, dormant seeds shiver and awaken. Tiny roots twitch, shoots unfurl, and stored energy begins to burst. Then, almost overnight, the harsh brown landscape can turn into vast swaths of color. Yellow, purple, red, pink. If it's really rare, big occurrence, it's called a super bloom. And when you come closer to look at the colorful earth, you will see millions of delicate flowers, all blooming at once. It can be so surprising, you may not even know to look. Sometimes they only appear in the night and are gone the next day. Let's explore through movement the way a seed lies dormant and waits in a small, confined shape. Can you make yourself into a little, compact, tight shape? You are waiting so patiently. Now, as you sense it's time to awaken, do you shiver? Do you go fast or slow? What would it feel like to press against shell and soil? What would it feel like to send roots down and carve upward, unfurling little shoots? Sometimes plants grow so slowly it can hardly be seen. Let's watch a time-lapse video of plants growing and try to make the movements that they do. Ready? Go. How did it go? Did you feel new ways to press and carve, stretch and expand? In movement, we can use our body to create shapes like low to the ground earth formations, medium level spreading out, and high into the sky and beyond. Let's try moving at a low level, using the landforms to inspire our movements. Can you bend your knees to get low? What kind of movements can you do that you've never tried before? Now, let's explore moving at a medium-high level. Try using your back. Can you use your elbows to lead you? What can you do that pushes and reaches to the highest point? Can you envision your energy exploding outward? When I say go, carve and stretch and bloom in any way you choose. Ready? Go!
That was great. Thanks, Deja. Now we're going to invite Jackie back to share some secrets about desert blooms.
Fantastic. That reminded me of some desert blooms called the evening primroses that actually take their cue from the sun setting. So we often think about plants where they respond to sunlight, but when these evening primroses detect the sun setting, their blooms pop open and you can actually hear it sometimes. They pop open so quickly. And the reason that they open at night is because moths come in, these night flying moths, and they pollinate the evening primroses. But back to the slide, just like a super bloom, or just like dancing, super blooms result from good timing. So if there is too much rain too early, then it'll be too cold for the flowers and for the seeds to sprout. And if the rain comes too late, it will have been too hot and the seeds don't germinate because they get fried. The wind is very important and the timing of the wind in the desert spring. It will pull moisture from seedlings if they've sprouted because the temperature and the rain were correct earlier. But if it's too windy, the seedlings won't make it, and then we won't have a super bloom. And then finally, the temperature. If it's too cold, then the seeds can't germinate. And if it's too hot, they will dry out and be more vulnerable to the wind. Next slide. Some things that are important to know is that super blooms can be a little bit fragile, even though they look like so many wildflowers. So there are some important rules about how to behave around a super bloom to make sure that those flowers can make seeds that might show up next year, or they might show up many, many years in the future. So one is to stay on established trails and roads. Don't walk off into the desert and on top of flowers. There might be little tiny seedlings there that you can't even see yet. Look, photograph, and admire the flowers, but don't pick them or sit on them or lay in the flower patch because that might damage them or damage some pollinators who are hard at work. You could volunteer with a nonprofit to take out weedy, non-native, and invasive species of plants that don't really belong there, but accidentally got there because of something that a human did or something that an animal might have done. And you can educate others about the value of wildflowers to people, to pollinators, and to the habitat for animals by talking to them about what you've learned. And then you can also plant native plants like the ones that are offered by the Utah Pollinator Program, which is run by the state of Utah. And if you apply, you can actually get some free native plants from the state of Utah that you can plant in your yard to attract pollinators and to maybe contribute to a super bloom one day. And that's it.
Thanks so much. Remember, you can share your artwork at any point, even in progress. We'd love to see it. We'll put the link for the Padlet in the chat. And now we're going to watch another quick video from Amy to connect back to the standards.
Let's make some connections to the standards. What wonderful opportunities we've had to learn not only about Utah deserts, but to connect them to our various art forms. Remember how we started with the USBE seed standards and in every grade examining the needs, the characteristics, the survival habits of living things, both plants and animals, in various ecosystems, and with today's webinar specifically, deserts. I always love the connections between language arts. Whenever we're using books, poetry, or even big ideas to invite students to speak and listen and to communicate, we're connecting back to the language arts. And in Samantha's presentation, when she referenced the poem about wind, we're making comprehension connections back to language arts. Whenever we invite students to determine the meaning of words, phrases, or figurative language, that's English language arts. I love how we had lots of opportunities to explore various fine arts standards. And going back to Samantha's presentation about wind, we explored various sounds and melodic patterns. And we listened to different instruments about wind as we think about what it sounds like, as we imagine the different melodic patterns connecting us back to those music standards. In visual arts, we did desert landscapes with Elisa, and we also learned more about discovering diatoms with Erin and Olivia. And I loved how Erin and Olivia specifically pointed out some of those standards in their specific activity. But with visual arts, I love the idea of investigating ideas through art making, whether we're creating our own paper or whether we're looking for patterns that naturally occur in the desert. All of these connect us back to visual art, using a variety of artistic processes and materials, and then constructing representations of maps and places that are part of our everyday Utah deserts. In dance, it was really fun to dance with Deja and to imagine that we were plants coming through that rough desert soil. And I especially appreciated the visual impact of watching those plants move and then thinking about the dance standards in terms of spatial relationships, levels, direction, pathways, near, mid, and far arrangements, as well as small, medium, and tall, and especially just the fluid, natural dance, movement, and locomotor and non-locomotor sequences connected back to plants in the desert. With drama, we had some time building a jackrabbit with Tamara. And with this, the goal is to imagine a character in its environment and to think about the physical movement, gesture, and sound as they move from space, create different shapes and energies. So as we think about the jackrabbit and how we can take the information that we know about the jackrabbit and put it into its different ecosystems, we're making those connections between problem solving and using our imagination to support artistic, dramatic-based choices. When we think about integration, then, the most important question for me is to say, what works for your school, your classroom, and your students? How can you make connections that make the learning sticky and relevant, the kind of learning that they remember years after leaving your classroom? And as we learn about what makes that kind of learning, integration is at its core. Teaching kids to make those connections between science and, like we did today, with music, drama, dance, and visual arts, and tying it back to English language arts, all of those connections help the learning to stick. It gives students an opportunity to apply and transfer what they're learning. Additionally, we can bring in collaboration opportunities as we integrate with the various art forms. We can help students learn to solve problems, engage in engineering design practices, to become more resilient and to become responsible as we think about how we interact with our environment and specifically our Utah deserts. It's been a pleasure to be with you. I hope you'll continue to make those connections with your students, strengthening not only the academic contents, but the fine arts contents and standards as well.
Great. I'm glad we could make those connections. In just a few minutes, we'll have a Q&A portion of the webinar. So this is when you'll want to put any questions that you have for our presenters into the chat. I saw a few come in. And if you want to address a specific person, you can just ask them.
Oh, let me change my camera. So I'm going to leave this little QR code on the screen for a minute, and I'm going to actually upload an image right now to the Padlet if I can. Um, I, as I was looking at your artwork in the Padlet before I presented, I saw some of you intrepid artists started doing the collage even before I taught it, which to me is awesome because that means that this is something that's easy and that we can have our students do. So I am going to share my screen and we're going to look at the Padlet together. Let's see. There we go. Okay. And so you still have time if you want to add something that you created today. Now, this was made quite a long time ago by a teenager. I love this, the mittens at Monument Valley and Delicate Arch. But let's see what you guys have made today. So this beautiful piece, I think it was called Flames Upon Flames, and I love the intense colors that we see there. And you know, when I have students making these papers, I often look at the paper and think, nope, that's too messy. And they look beautiful when we turn them into these little collages. I love the plants here that are framing the front of the page and the really deep red landscape cliffs there. Excellent jackrabbit. I love the vessels in the ears to show us that that jackrabbit can cool down. Let's see. We have 27 works of art. Awesome. They're darling. Okay, beautiful. I love that sandy texture in the bottom. And this right here where we can see these beautiful outlines of the landscape, that's one of the reasons why I really love this project is because students have to think about how can I really carefully mimic what I'm seeing in the images. Awesome. This is a good collection of multiple projects. Beautiful. Look, we can see this is the West Desert image here. Oh, this is the pop-up card that I made and how I finished the piece that I started together with you. Excellent diatoms. And so love that there are these microscopic little tiny things and we're envisioning them larger. This one really makes me think of the artist that we looked at the beginning. Her name escapes me now. Ooh, this shows how we can see the sky peeking out through these landforms. Excellent. Cool. This artist chose to do some ripping. I'm always a fan of ripped paper. Beautiful. Wow, even some really delicate cutting here in the front. And I love the dark purple as we're seeing those mountains far in the distance. Same image. Awesome. Beautiful. I'm delighted at how many of you shared your artwork. This is so cool. And I really love the sky, leaving the white in the sky so we can see those clouds. Beautiful. Wow. So cool. Excellent. I love seeing that somebody did try the dish soap project, and I love those colors. Beautiful. We'll share this Padlet with you. So go ahead and keep adding your artwork if you'd like to, and then you can share these with your students as well. Okay, thanks.
That was some amazing artwork. Thank you so much. We're just going to quickly revisit our learning intentions and success criteria. We hope you have at least one idea of how you can integrate science of Utah's desert habitats and an art form into your classroom, and that you can see the intersections and alignments between the USB standards. Also, we want to invite you, we would love to see your work or the work that your students do. If you use any of these ideas or activities from tonight's webinar, we'd love to see photos. If you send us photos specifically to Samantha by June 12th, we will enter you to win a $50 Amazon gift card. You'll be receiving information about how to do that later on. And now we're going to do the Q&A. So we're going to invite everyone, all the presenters to turn their cameras back on. and then we will field some questions.
All right, we've had a few questions come through the chat. One person has a question for Elisa. Said, I like the pre-made patterns. Do you have, this is about your painted paper, do you have resources on how you decided how or what to have pre-painted?
Um, no, well, just what I said there at the beginning, really have the students look at the photograph that you want to use as the inspiration for their project and have them analyze what am I seeing, what colors am I seeing here? Is this the bright orange in the bottle, or do I maybe need to add a little bit of a different color to mute it down a little bit? Do I need to have streaks here, or do I need to have speckles? All of that paper we made in, I don't know, half an hour of just mixing and messing and getting messy. But think about what you see in the landscape and use that as an inspiration for the colors that you create. Let the students have one fun painting day where they're all going crazy. But again, each table can have like a color palette that they're working with, not every color at every table. And then the next day when you come back together, share the papers across the room so they have access to everything that you created. I guess that's my answer.
Great, thanks. I have a question for Jackie. Um, this is a question for me, but one time we were talking about super blooms and fire, and you said something really interesting about what you're seeing in some places in southern Utah this year because of the fire season we had last year. And I was wondering if you would briefly talk about that a little bit.
Yeah, absolutely. So there are several plants, and I think Deja mentioned this, that are triggered by the chemicals in smoke. One of them is a tobacco, a native tobacco that lives here and also blooms at night and attracts the moths. And another one that we found this year was a plant called the Phacelia. But basically, what happens is the seeds sit in the sand or the clay or whatever they happen to be in for sometimes many, many years, like decades. And then the fire burns, and it's a combination of the temperature of the fire and the chemicals in the smoke that the seeds detect and that triggers them to bloom. They know that the junipers and the pinyon have all been burned away now because of that signal in the smoke, and it releases them from their dormant state so that they can bloom in huge numbers, sometimes by the hundreds of thousands.
Great, thanks. Another comment in the chat was an idea. It was also about the papers. They said, here's an idea regarding the pre-made patterns. You could try creating chalk prints using shaved chalk on water and then lift it off the water and onto paper and use those for the pattern paper. I think that's a really interesting idea. Are there any other questions to put in the chat? That's all we have so far, but you still have a chance.
I have a question for you, Samantha. I love the idea of having students arrange a familiar piece of music. And so, can you tell me what ages or how young you've done an activity like that, where the students are
Totally.
arranging?
Yeah, you can really do that with any age as long as you adjust what you're asking them to do. So with very young students, I would maybe only give a few choices and kind of say, okay, our choices are to sing the song, to play these instruments, and to do this one other thing, maybe a movement activity. And we can say, what order should we do it in? How many times should we sing it before we do the movement? And then should we sing again? And should we do the instruments? So that basic building block of kind of you can almost have cards and then move them around on a whiteboard or something. And that basic activity of them taking ownership and making decisions about music really sows the seed of them starting to create. Or with older elementary kids, they can take things that you've done in class with that piece or come up with their own ideas as well.
Thanks. I love that idea of the cards for the really young children.
It's also a really good idea, activity for centers if you have kids in small groups, and then they can work together to do that too. Two questions just came in. Three questions came in. If an environment isn't windy, can we call it a desert? Do deserts have to be windy?
Sometimes you're in the desert and it's quite still, but we get seasonal patterns of winds in the desert. So there may be spring winds or fall winds or winter winds, but that doesn't mean that it's windy all day in the desert. And then we will get patterns of wind during the day and during the night. Because the desert is so bare, the temperature differential is quite large. And when it's hot during the day, it gets so cold at night that that causes a transfer of energy in the form of wind. So, yes, you can be in a desert that's not windy, but it probably will be windy at some point or the other.
Thanks. All right, we'll do these last two questions, then we'll move on. Um, this one's a dance question. I teach fifth and sixth, so this is for Deja. They are too embarrassed to move. Any suggestions?
Yes, it doesn't have to be presented in such a dancey way. It could be more movement as athletics or sports. It could be movement in pairs. I find that often works well to have two people working together facing each other and just mirroring each other's movements. So they have an objective, but they're working, focusing each other rather than looking at the whole group. And that's a way to, feel a little more confined in expressing and confident and have a little support behind it. So I think there's ways to make the dance there more movement that feels safe, like just introducing basic steps like skip, hop, leap, movements of the upper body that are more like sports style and kind of work it in to build a sequence that feels a little more safe.
Thanks. All right, last question. How colorful are diatoms in real life? I
Sure
love this
thing.
question.
Mm-hmm.
Yeah, diatoms are mostly transparent and green because of the chlorophyll inside of them. But depending on the type of microscope that is used to look at the diatom, that's when they become iridescent because of the light that is shined on, if shine's the right word. Anyway, when you look at them under the different types of microscopes, that's when they get that opalescent look about them because the frustule, the silica, is very reflective and rainbow-like when the light is on them. So transparent and green, not as exciting unless you have the right microscope.
Right. These are great questions. That is, I think, all that we have time for tomorrow. You can go ahead with the next thing.
Great. When you leave this webinar, the survey will open in your browser window. It'll open as a Zoom page, and you will need to click the continue button to open the actual survey. You must complete the survey to receive your licensure hours. After we receive your completed survey, we will load your relicensure hours into Midas. We will also email you a link to the Google folder with all the information and resources from today's webinar, as well as a recording of this webinar that will be uploaded to our YouTube channel, and we'll give you the link for that. You should receive your relicensure hours and the Google folder by Friday, April 24th. Thank you all for joining us for today's webinar, Secrets of the Desert. We will stay on the webinar for just a few more minutes if there's any final questions. Thank you so much.